Hi, in this video I will talk about vector geometry, which is a continuation of the previous videos about vector definition, representation, and also vector operation. Okay, let's just make a start. In vector geometry, we will come to see the term coplanar vectors uh, many times. So let's clarify the definition. So coplanar vectors are vectors lying on the same plane, such as all of these vectors, vector A, B, C, D, they all lies on plane M. If vectors lie on the same plane, then we can conduct vector operation. Okay. Here is another example. In a cube, there's vector BD. Okay, vector BD lies on a plane A, B, C, D. Okay, and another vector, vector A, C1, lies on a plane A, A1, C1, and C. Okay, you probably have come across this in science or physics. This is a free body diagram of a chart being pushed up. So there's a force pushing that way at an incline, and of course the friction goes to the opposite direction, and weight pointing downward, and there's a normal reaction. So we can conduct vector operation to all of these vectors because they're all lie on the same plane. Okay, let's go straight to the example. Okay, take a look at example A. So this is the plane, the triangle, so we can conduct a vector operation. So on triangle OAB, there are vectors A and B, and also given uh, length OX, the ratio of length OX to OXB is equal to 1 to 3. So you are asked to find vector AX in terms of vector A and vector B. And vector AX, okay, that's AX. Vector AX is equal to negative vector A because it goes to the opposite direction, plus OX, which is 1 over 4 a vector OB, right? And vector OB, that's OB in terms of AB, is equal to A plus B. Okay, and then you simplify to get the answer. Okay, that answer there. Okay, next, example B. Again, the vectors lies on the same plane, the triangular plane, OAB, okay, given vector A and vector B, and also the ratio of length AY to YB is equal to 2 to 3, so that is 2 to 3. And you are asked to find vector OY in terms of A and B. Okay, so vector OY, which is equal to vector A plus this segment here is 2. Okay, AY is 2 over 5 of vector AB. Right? And vector AB, okay, vector AB is equal to negative vector A plus vector B. And then you simplify to get this final answer. Okay, nothing difficult, very straightforward. Okay, take a look at this example. Show that yx, vector yx, that is parallel to vector AC. So show that vector yx is parallel to vector AC. And what is the ratio of yx to ac, given all of this information. Okay, let's put this information first into the diagram. Okay, so this is vector r, and this is vector s, okay, based on the information given. Okay, show that yx is parallel to ac. So let's find vector ac first. Vector ac is equal to, that's ac is equal to r plus s. And then we need to find yx, vector yx. Vector yx is equal to yd plus dx. And yd is 2/3. So this is yd 2/3 of ad. And dx, sorry, dx is 1/3 of db. Okay, and ad, okay, so since the answer must be in terms of r and s, so we have to replace this ad, so that's ad is equal to vector r plus vector bd. Okay, right, and next we have to replace db in terms of r and s. Okay, so db is equal to negative vector s plus vector r, okay, or r minus s. And then you simplify to get the final answer, right? And notice that ac and yx, they are multiples of each other. Therefore, they are parallel. If you look at the previous concept, okay, this one here, if different size vectors have the same or opposite direction, they are scalar multiples of each other, meaning they are parallel. Same direction, although different size. And see, this is vector m is equal to k multiplied by vector n, and k is just a scalar, a number, right? So they must be multiples of each other to be parallel. Same thing with this one here. Okay, ac is equal to r plus s, yx is equal to 1/3 by r plus s. So they are multiples of each other. And then what is the ratio of yx to ac? Well, of course, 1:3. Okay, there you go. Okay, let's look at this exam question example. In the exam, the first question, just like in the previous example, they will ask you just a simple question, and on the second part, you ask to find a Hada vector using the answer that you find in part A. Okay, let's take a look. Okay, this is the plane, yeah, PQRS, a parallelogram. N is the point on SQ such that Sn, the ratio of Sn to Nq is equal to 3:2. And given that vector PQ is equal to vector A, vector PS is equal to vector B. Okay, question A is supposed to be the easier one. Okay, find the easier vector. Write down in terms of A and B an expression for SQ. SQ in terms of A and B. Obviously, SQ is equal to negative B. So from S to Q, that's equal to negative vector B plus vector A. Okay, and then part B, you are asked to express vector nr in terms of A and B. Okay, this is nr. Express vector nr in terms of A and B? Well, you can go that way, of course, or you can go this way. Okay, which one to choose? Well, in part A, we are asked to find SQ. Therefore, we must use this answer of part A to the B. So therefore, we have to use this direction because this is of the same direction to SQ, right? There you go. So NR, vector NR is equal to 2/5 of SQ plus vector B. Okay, this is vector B because this is a parallelogram, so this side here is parallel to this side here, right? And now we can replace vector SQ with the answer of part A, okay, and simplify to get the answer. Okay. Okay, next, finding the magnitude of a vector. Okay, again, a vector is a quantity that has a direction and also magnitude. Yeah, so the magnitude or modulus of a vector is given by the length. Obviously, it's given by the length of the line segment that represent the vector. For example, suppose we have vector AB is equal to vector A and have the column vector of 4, -2, right? So 4 unit to the right, 1, 2, 3, 4, and 2 unit down. Okay, and if you are asked to find the length or the magnitude of vector AB, and this is the notation of magnitude of vector AB or modulus, yeah, of vector AB, what you do is use Pythagoras, right, to find this length. Very easy. Okay, there you go. So to find the magnitude uh, of a vector, you use Pythagoras theorem. Okay, here's another one. Express each of the following as column vector and find its magnitude. Okay, so vector PQ is equal to -2, 3 because it goes 2 units to the left and 3 units up, and then you use Pythagoras, okay, to find the magnitude or find the modulus. Same thing goes with vector RS. Okay, the column vector is 4, 0, 4 unit to the right, okay, and there's no vertical movement. And then you apply this into Pythagoras. The answer is 4 units. Yeah. Okay. Lastly, well, this is actually, oh, sorry, still in the distant formula. Um, Given point P and Q, then you can use this distant formula to find the magnitude as well. Same thing, just like using the Pythagoras. All right. Okay. All right. Okay, let's take a look at this example. If you are given 2 points and you are asked to find the magnitude, okay, all you do is subtract correspondingly. So the magnitude of vector PQ is equal to the square root of 5 minus 1. So you subtract those x's. Order doesn't actually matter because power of 2 applies. Okay, and then you subtract the respective y. That's 3 minus 1. Okay, again, order doesn't matter because there's a power of 2. Okay, and there you go. That is the magnitude of vector PQ. Some additional note. Um, this belongs to position vector, actually, I should have mentioned this at the very beginning, but that's alright. So if you're given vector A equal to 3, 7, then the coordinate of A will be 3, 7. Yeah, because you measure from the origin 1, 2, 3 unit to the right and 7 unit up, and this is vector A. Similarly, if vector B is equal to 8, 4, then the coordinate of B will be uh, 0.84, 8 unit to the right and 4 units up. And if you are asked to find the column vector of AB, okay, so column vector of AB is equal, you will answer that's equal to uh, 1, 2, 3, 4, 5, 5 units to the right and 3 units down, so that's 5, 5 and negative 3, right? But you can also use this formula. If you're asked to find the column vector of vector AB, okay, let's put it that way, that is also equal to vector OB minus vector OA, or B minus A. Okay? And we know that vector B is equal to 8, 4, and vector A is equal to 3, 7. So the answer is 5 minus 3. Okay, so this is another option to the counting the direction, the horizontal vertical direction. You can do directly uh, subtract B, vector B and vector A. Or for example, if they ask you to find vector CD, that's just equal to D minus C. Okay, thank you very much for watching. I hope this helps.